Yeah, so as my introduction may have revealed, I am a former data scientist, now turned architect very recently. So a bit of cross-disciplinary span. So it seems to be in trend in this conference for everyone to give their own definition of MLOps. So I'm going to throw my hat in the ring with so how I frame my thinking around MLOps. I think, in a nutshell, it's basically how are we going to do machine learning at scale while maintaining quality. And I'm essentially going to frame my talk around. Sorry, oops, I've skipped over 2 slides there. Around digging into this definition for the BBC and what this means for us. So first off, what is the BBC doing in the machine learning space? Well, the BBC has a very large audience base. Around 90% of the UK population will access at least one BBC service per week. And we have around 468 million users worldwide. And I'm not sure entirely how up-to-date these figures are because I stole them from someone else's presentation, but give or take, that is our reach. And in addition to having lots of users, we also have lots of content. This is not an exhaustive list, but you are probably familiar with at least some of these products: Sounds, iPlayer, News, World Service, and Sport. So when we're thinking about machine learning, the main problem that we're trying to solve is how do we help each audience member find the content that's most relevant to them on the BBC. So this is the problem of making content discoverable to offer value to audiences. And in that space, machine-driven recommendations have been shown through experimentation to offer a lot of value. There are lots of different types of recommendation live on the BBC. Some of them are personalized, some of them are not. So for the personalized recommendations on products like Sounds and iPlayer, you have recommended for you rails, which will be based on your own user history. Then on the non-personalized, there's related content that will be surfaced next to news articles, sport articles, World Service. We also have sorting of editorially curated rails, such as I think you can see that Get Lost in a Story rail at the back there, which will be sorted based on your own profile. So there are other use cases for machine learning at the BBC. There's been some exploration of auto-tagging content, looking at sort of interactions with Alexa and Siri, and some interesting work being done in the archive and R&D. But in terms of the BBC's greatest maturity, that lies in the recommendation space for machine learning. So in this presentation, when I'm talking about machine learning, I'm going to be focusing on the recommendations use case for the purpose of content discovery. So as I've mentioned, this sort of scale that we're talking about in the BBC is not just in terms of number of users, but it's also in terms of number of products that we're serving. With such a large range of products we're supporting, how do we engage efficiently with all of these use cases? I'm going to answer this question by focusing on a particular recommender that I built with my previous team. This was a recommendation engine for related content on BBC Sport. Particularly, it was for short-form video clips. Sport has a lot of these, so highlights of matches, interviews, commentary. And we wanted, or the sort of product owners wanted, a recommendation engine that would offer non-personalized onward journeys. So that sort of related bar on the next to the content that would be the same for all users viewing the page. So to do this non-personalized type of recommendation, there's 2 real signals that we can use. The first is content-based affinity between clips. So information such as the clip headline, summary, tags, the timestamp, the sports category that it falls into, all of these can be used to generate thematic similarity between different clips. In addition to the content-based similarity signal, we additionally use a collaborative signal. So for those of you who are familiar with recommendations, there are 2 types of collaborative filtering: content-based and user-based and item-based. For non-personalized recommendations, you're really relying on the item-based collaborative filtering. So essentially, if item A and item B have very frequently been viewed together in user journeys, then if a user lands on item A, we'll recommend item B. So this is essentially grouping together co-consumed content. So based on these two signals, I'm going to talk through the very simplified version of the architecture that we built. So for the content-based similarity, this required us to have an article metadata pipeline. For this, we use Kafka. We have all the sort of updates for content, so publish events, updates, deletes of our content on BBC Sport. Our messages are written for those to a Kafka topic. We have a data processing module that subscribes to the Kafka topic and extracts and processes the relevant features from that metadata and writes those to a feature store. So that's how we bring in the thematic similarity of content. For the collaborative signal, we use user history data, so we have a user histories pipeline. Misleadingly, this makes it look like a streaming process. It's actually a sort of high-frequency batch process. We're pulling in the user history data in 15-minute intervals and writing that activity to a BigQuery table. We then have a model training pipeline that runs 3 times a day in Airflow, pulls the user history from BigQuery, trains the collaborative filtering model, and this generates embeddings, which essentially represent how closely related articles or clips are in content space. And then those embeddings are written also to our feature store. This automated frequent retraining is really important for us because, especially in a sort of news context, it's you want to be recommending the freshest content at all times. And if we don't have user histories that are containing an item, we have no idea which other items it's related to in that content space. So we need to be, as soon as new content is published, our model becomes out of date. So we need to be frequently retraining this so that we can capture signals from newly published content. We then, on top of this, have a front-end query a front-end recommendations API that runs queries against the feature store. These queries is a combination of approximate nearest neighbors between the collaborative filtering embeddings and then TF-IDF on the text-based features. And then on top of that, we layer business rules which ensure certain aspects of editorial quality, such as restricting articles to enforcing a sort of maximum age of content that we surface, that kind of thing. We then sort of weight these different scores and combine them to rank our content in terms of relevance to the seed article. We additionally have a cache, which is necessary for meeting our SLAs. Fortunately, very good use can be made of the cache for non-personalized recommendations because you have a comparatively small number of video clips relative to the number of requests that are being made. And so with the cache in place, we were able to serve these recommendations within the sort of 200 millisecond SLA that Sport required. So this went into production a while ago, and it generated a really huge uplift in the engagement with sport videos. On some, particularly on some niche sport sites, we were seeing like 30% increases in onward journeys going on from those pages. So it was really good. But the caveat was that end-to-end, full disclosure, this took us an entire year to build. The upside was we were thinking, as we were building this, about how we were going to extend it. So we were using lots of reusable components and patterns, infrastructure as code using Terraform, CI/CD using Cloud Build, so automated lint unit and integration testing for all of our components. We were doing deployments using Kubernetes. So because we had a focus on reusability, when it came to adding some more services, we were then able to roll out the next 2 recommendation engines for 2 of our World Service sites, Brazil and Turkish, in just a quarter. This was still slower than we'd like, so we took another look at the stack and thought about how we could increase the automation even further. We, for instance, added automated backfills from our Kafka topic, so it was very easy for us to introduce new features and iterate that way. And we basically got this expansion to across world service languages happening more and more quickly. And the next 2 sites took us 2 weeks to add, and it now just takes a day or 2 for us to onboard a new onward journey recommendation engine for a new world service language. The slowest part of the process is actually the editorial feedback process that we are required to go through before putting these models live into production, just to make sure that they meet all of the BBC's standards, and I'm going to come back to that a bit later in the talk. But yeah, this quick iteration is really important because we have over 40 language services on World Service alone. And as I mentioned at the beginning, it's not just World Service. There's iPlayer, there's Sounds, there's Bite Size, News, all of these different BBC products. And this is just for a single recommendation use case. So this is just for the case of recommending related content to that single page that you've landed on. So in addition to that, we have many different types of recommendations that we need to manage. So we have personalized rails, we have algorithmic, we have sorting of editorially created content. So a lot of different use cases. So coming back to that original definition of MLOps, what we're really talking about with scale is how do we interact with this large number of products? And the key thing for us is has been focusing on these reusable components and patterns so that we can, once we've built something and it works, we can roll it out quickly to lots of different services. The final part of this definition is quality. And I think this is sometimes overlooked in favor of that sort of speed and time to production element. But for me, I think this is the most interesting part of the definition, how we maintain quality when we're massively scaling up our machine learning across an organization. I don't know how many of you have seen this schematic. I'm surprised no one else has shown this yet, because I suppose this is for me, this is the kind of quintessential schematic to motivate MLOps. You're seeing on the y-axis the value of a machine learning model to a business, and on the x-axis is over time. And so what it's showing is that you get this initial boost in value when your model goes live. But if that model was trained offline, then there's going to be degradation due to data drift and then these various other forms that will result in the various losses of value as your model goes out of date. So I'm just going to talk through those quickly. Yeah, so in the short term, if a model's been trained offline, then the first loss in value you see is due to data drift. And in the context of our content recommender, this is those new articles being published that aren't included in any user journeys because our model was trained before that article was live on the BBC site. So this is, to avoid this data drift, is why we have the automated retraining and deployment of our model using Airflow. So that's great. You get the value back up when you retrain, but perhaps something bigger goes wrong when you have this catastrophic failure. Maybe one of your upstream fields has changed in your pipeline and your model can't handle it, and everything explodes and you stop serving recommendations. This makes stakeholders, unsurprisingly, not very happy. So it's important to have monitoring and alerting in place to make sure that you're aware of any pipeline failures. Currently at the BBC, what this looks like to us is we get a Slack notification and then we have to go and do some manual debugging and redeployment. The next step that we're focusing on is having an automated rollback so that we can sort of smooth out that process and not have that downtime in our model. And then the final longer-term form of degradation you might see in your model is concept drift. So this is what happens when the initial modeling assumptions that you made when you were building your model cease to be relevant. So for the BBC, this might be that some assumptions that we made about audience characteristics might cease to be true, or perhaps there are different requirements in what the product owners want from their recommendations. So on this longer time scale, our model will start to lose value because of that. So it's really important that we keep our models relevant by iterating on them. But then the only way that we can tell that the iterations are offering any value is by experimenting. So this is why it's important to have a culture of A/B testing. But I've kind of rushed through all this, brushing over what we actually mean by model value. I think it's quite often, to a data scientist, they sort of like to have a simple F1 score they can look at. To more corporate enterprises, this value is the revenue generated, number of sales, whatever. But at the BBC, when we're thinking about value, we think about it a bit more broadly because we're a public service organization. So the BBC's public service values, you might have heard the sort of motto of inform, educate, entertain. And what that sort of means in a recommendations context is making sure that we're not getting people trapped in filter bubbles. We're not just serving them the things that will generate the highest click-through rates, but we're really serving a diverse range of content and representing all of our audiences, particularly the underserved audience members. I think the kind of key point for other organizations, something I see a lot is, we're data people. We like to have a metric, but just because a single proxy exists, it doesn't necessarily mean that that's what you're trying to measure. So I think examining the figures that you're using to determine value is really important, and not just settling for one because it's the easiest to measure. In the BBC, we've developed a set of machine learning engine principles, and the purpose of these is to ensure that machine learning is offering public service value. And this is more than just sort of documentation that sits unused on a shelf somewhere. This is an actionable process that teams go through when they're developing a new recommendation engine. And it involves engagement from editorial staff, from product and project owners, from data scientists, so really, everybody who's working on this project. And if you want to implement something similar in your organization, this is available freely online, so check it out. So coming back to that question of quality, I covered quickly that we are using these sort of standard MLOps techniques to maintain quality, so automated retraining, and deployments to mitigate data drift, the monitoring and alerting for model failure, A/B testing for improvements. But I think that the sort of bit I want to pull out is that how we think about quality is more than just a click-through rate, and we are really very focused on the diversity of recommendations in terms of the content that's surfaced and the audience members that are served. So in summary, coming back to this original question of what does MLOps mean for the BBC, we are most developed in the recommendation space, so solving this problem of matching audience members with the most relevant and the best BBC content. We have a large number of products and recommendation engine use cases, so making sure that we can serve all of these different recommendation engines means that we rely heavily on reusable components and patterns. And this is essential for reducing that time to production. We have sort of various MLOps techniques implemented to maintain value over time. So that automated training to mitigate data drift, monitoring and alerting to mitigate model failure, and experimentation to mitigate concept drift. And finally, there isn't one simple metric that we're using to evaluate our model quality. We think about value in much more than just a click-through rate, and we have a process for ensuring that new engines offer value, and we monitor for diversity of recommendations as well as just audience engagement. So that's it.